discussed about the introduction to amplitude shift key. So in the digital communication, when the digital signal is weak, we apply modulation techniques. So among all the modulation techniques, there are three important, the major things, that is ASK, FSK and PSK. So as you know, in module 1, we have discussed about amplitude modulation, frequency modulation and phase modulation. Similarly, we are going to discuss about ASK, FSK and PSK in digital communication. So the difference between analog and digital is there we take analog message signal, here we take digital message signal. So today's objective is, we will discuss about the complete ASK, what is the input and corresponding output. We will see what is FSK and PSK. So in last class we have seen the definition of ASK, right? So the amplitude of the carrier is varied with respect to the digital message signal, keeping frequency and phase terms constant. So if you see this is a digital message signal which is represented as VM of T. So VM of T consists of logic 1, logic 0, simply digital will have zeros and ones, right? So in the zeros and ones we clearly mention this as logic 1 condition, this as a logic 0 condition. And the amplitude of this positive voltage is given as +1 and the amplitude of this negative voltage is taken as -1 in this way. The carrier signal is represented as AC cos 2 pi FCT and we see the corresponding output how we are going to get. So this is an amplitude shifting equation which we have discussed in the last class, that is VASK of T equal to AC by 2 into 1 plus VM of T cos 2 pi FC. So this VM of T is the representation of a digital message. So now let us find out for logic 1 condition what is the corresponding output and what for logic 0 condition what is the corresponding output. So for logic 1 condition, so it means that your voltage of the message signal VM of T is equal to +1. So if you can see for logic 1 condition the voltage of the message signal is given as +1. It means that VM of T is equal to +1 for logic 0 condition. For logic 1 condition, so VM of T is equal to -1 for logic 0 condition. Now let us substitute this logic 1 and logic 0 in the equation and let us see what is the output we are going to get. So now for logic 1 condition, the ASK of T is equal to AC by 2 into 1 plus, so what is VM of T for logic 1? It is +1. So in the place of VM of T, we are going to replace it with +1 and remaining things as it is will go like this, that is cos 2 pi FC. So your final expression will be AC by 2, 1 plus 1 is 2 cos 2 pi FCT, where 2 and 2 gets cancelled. So the corresponding output is AC cos 2 pi FCT, which is a representation of a carrier signal. This is a carrier signal equation. So it means that for logic 1 condition, so when you apply this carrier as a support to increase the strength of the message signal, the corresponding output we are going to get is the carrier as it is. Now let us see what is the corresponding waveform output for logic 0 condition. So logic 0 means your VM of T becomes -1. So if VM of T is equal to -1, then logic 0 is AC by 2 into 1. VM of T is -1, 1 minus 1 cos 2 pi FCT, which is equal to, what is the answer? 1. So VASK of T is equal to 0. So it means that very simple. To compute this amplitude shift E. So when you take digital message signal and carrier signal and modulate them, multiply them, the corresponding output will be for logic 1 the carrier is present as it is. For logic 0 the carrier is off. The carrier is not present. So the amplitude is shifting from one place to another place like a key. So the key will have two options, either open or close. Similarly, the corresponding output will have two options. For logic 1 it is carrier present, for logic 0 the carrier is absent. So this condition we call it as, that's the name, we call it as amplitude shift key. So this is also known as on-off keying method. We call it as on-off keying method. That's another name for ASK. Why we call it on-off? For logic 1 the carrier is on, for logic 0 the carrier is off, carrier is absent. So this kind of keying method we call it as on-off keying method. So this is about the amplitude part. So till now we worked on only amplitude. So your frequency is kept constant. You can see there is no frequency change here. Even the phase of the signal is kept constant. Only we worked reason we call it as amplitude shift key. Now the second one is the frequency shift key. So we are going to change the frequency component and we are going to make amplitude and phase terms constant. So the definition of FSK is, so as we discussed in the last class, the frequency of the carrier is varied with respect to the digital message signal, keeping amplitude and phase terms constant, right? So I want you to just look into the definition once again. So the definition of FSK, the frequency of carrier is varied with respect to the digital message signal, keeping amplitude and phase terms constant.